Oh,
Hello.
oh, hey, Marco. How are you doing, sir?
Hi. I'm doing well, thank you. And you?
Oh, honestly, I didn't sleep at all last night in
Ah.
excitement for this live stream.
I don't believe it.
Yeah, my wife was like, "Are you okay? Are you feeling all right? Do we need to go to the hospital?" I'm like, "No, I'm
No.
fine. I'm excited." This is so we kind of mentioned this a little bit earlier. Like I don't do sports. I don't do like other stuff. All I do is like data. So this is like talking to a rock star. So thank you for joining us.
Come on. No, come on. Thank you. Thank you for hosting the event. I'm glad to be here.
Oh, so excited to have you here, and thank you everyone for joining in. This is well, right off the bat, we're clearly exceeding what I have for my normal live stream. So that's all clearly you, Marco. So well done.
Mm. I don't know. Yeah. Let's try to provide something interesting. I don't know. We'll see.
Well, and I think we actually do have a fantastic conversation here. So I'm very excited about to get into that. But before we dive into that, I do want to welcome everyone in the chat. You know, I'm seeing
Yeah, I see the
tons.
chat here. Yeah.
Holy cow, we got lots of people, and so
Yeah.
on YouTube, tons of people coming in. On LinkedIn, we have a whole bunch of people. We even have a few people on Twitter, so or X or whatever they call it. So that's exciting to see everyone joining us here. Um, so welcome everyone. Please, we're going to be getting into questions really pretty quickly here, and there's a lot more than I'm accustomed to. So please, we follow Guy and Cube rules. Matthew Roche commentary. Please prefix all questions with a Q, so we can get them queued up to get into Marco. And anyone who's spamming, please don't repeat questions. The moderators here will block you or temporarily from hitting us. So please don't do that. But today the topic is going to be best practices and
Yeah.
why it's important.
I,
Okay.
I, yeah,
Um,
because yeah, it's they're important. Otherwise, they would not be best practices. That's
right. And I think it's important to understand the value of them because most of the time it takes effort to do it. Right? It's not natural. It's not easy sometimes. So understanding and being able to articulate that value is important. But before we get into that, this is a question I ask like everyone when they come on the live stream. I would like to know, like, how did 5-year-old Marco go from wanting to be a firefighter or a superhero or a police officer, whatever it was you were looking forward to do as a child, to where you are today? Could you just like run us through that journey of
uh, it's it's hard and easy at the same time because you know, when I started to speak, no, actually not that, but already at the primary school, that the idea is that I want to write program, I want to code on, I want to use computers. That was the idea. And so I started as a developer, coding, programming.
how old was it when you first started doing coding?
14,
Wow.
14
Okay.
years old.
All
Yeah.
right. So and then you just started, and were you? Did your school have this, or did your parents have to buy you a
No, no,
computer?
no,
How?
no, 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 no,
No.
no, 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 totally no. It's just started with yeah, let's say internet was not around, and so it was difficult also to collect the information to learn. Besides, I didn't speak English at that time, so there was the
Mm.
additional language barrier. So most of the content was in English, and not much was translated in Italian. And of course, that was an additional. But again, it didn't matter. I mean, I was so attracted by the computer, so I just started, and
Oh.
I started to write programs and coding, and of course, then But at school, it was always, oh, I know that. Come on, let's do something else. So because if you start, I mean, now it's different. I will never suggest someone to. Oh, okay, so if you want to be a professional developer, um, you can technically learn alone. Just go, now in ChatGPT, or you Google, or you use search engines, you search for, also without spending a fortune in courses, you can learn. But it's likely that you will not learn some foundational concepts that are important to understand what is going on. Um,
Sure.
so, for example, if you know, potentially you could, with the AI, no, but in a computer without AI, let's say an algorithm program, you can actually technically say, okay, what happens for every bit that is around in your computer. So potentially you can. Um, but this requires a deep knowledge about, from the hardware, the operating system, and many other things. You might say, well, we don't need it. We do just data. I agree, but someone has to know that, and those, that kind of awareness of what is going on is what is important when you have to troubleshoot also performance issue in DAX, for example. If you want to really understand what is going on, or it's a RAM problem, it's a IO problem, it's something like that. Deeply understanding this requires a foundational knowledge that is hard to achieve just by learning by yourself. It's not impossible. It's just that it's hard to find a motivation to learn all these details. Whereas if you have a structured program, now you learn what is bit and bytes, and from there you move up. You have a guidance, and also you have more connections. You are more, you face more, many other point of views. You also have to challenge your teachers, because maybe they think something different. So it's
Uh,
it's a good experience. It's not necessary, but I would say, why you want to make your life harder?
yeah, and I think there's now many more communities, right? You can join live streams like this. You can get involved in the Q&A, and as you said, be able to ask questions and stay on a narrow path, and keep you moving to that goal is now easier than ever before. Uh, but also, to your point, like knowing that you should understand how the computer works, and how memory functions, and how processors relate to your performance of what's going on. Honestly, I think that's been one of the bigger things that's helped me in building models. Is like, okay, I'm thinking about, on some level, how am I handling my memory, right? How is my threading going on? So yeah, I think that makes great sense, Marco. Holy cow. All right, we are getting into let's just go ahead and get into
Yep.
this, because I think we're leading right into this. So I wanted to talk to you about like the value of best practices, and
Yep.
the first frame I was thinking about is, and maybe this is leading right into it. Um as an individual, from your perspective, Marco, what is what's the value and the rationale for learning what the best practices are and starting off on that journey?
To have time to watch a movie in the evening, for example, because I mean, the best practice. So there are pros and cons as in everything. But when we say, "Oh, there is a best practice," it means that it's what you should do by default, uh, and you should provide a very good reason to do something different. That's the way I see the best practice. So I don't see the best practice as, "Oh, we have to do that at any cost." That's not the point. The best practice is, usually this is, many people face the same issue before, and they found that this is usually the best way to solve this problem. Your problem could be different, and you could have a good reason, a very good one, to do something different. Probably you have to explain why, because otherwise, one of the fundamental skills, statistics. With
Mhm.
statistics, you learn how to not lose too much money when you go to the casino, which is a very important skill. And then you also learn how to uh, spend more time trying to optimize a program if you code in C Sharp, Python, or whatever. And also when it comes to databases or data science, or it's a good skill to understand what is going on. So based on the statistics, best practice is the way most of the times that problem could be solved in a more efficient way. So it's a good idea and a very good use of your time if you learn the best practices, just because you could be faster in solve the problems and having time for a regular life that many other people that wrote the best practices don't have. So why not taking advantage of the you know the time spent by other people writing those things.
Right. The whole like standing on the shoulders of giants, or
Yeah.
as Paul Turley said, because Marco said so. So, um, yeah.
As it's not that someone said that, is because probably let's say, it's not Marco, is when there is a common, so when in an industry, not just in our industry, uh, there is something known as a best practice, usually is because it has been tested and validated in many different scenarios. And again, it's usually let's say that a best practice that has been written in just one book and is not found anywhere else, it's a suggestion, it's not a best practice. So a best practice is what is acknowledged by many other people in the industry, like in other areas in science. Oh, we do this, doctors, you go in a hospital, a best practice is the way we usually treat this disease. But of course, there are cases where we do something different, but 90% of the time this works. So we try that first, and then we see if we have to do something else.
and I think that just gets back to your whole efficiency thing, right? Like it helps you get your job done faster.
Yeah.
You can predict your timelines for your efforts, so you can like lay out and say, hey, here's how I'm going to do this. And most importantly, as you said, free up your nights and weekends from supporting things that aren't going to be performant at work. Um, that is great. We have some questions here from chat. We're going to hit on
Yeah,
one
I
of
see
them.
there are many questions. Yeah,
Yeah,
wow.
yeah. So we have a two-parter from Nicholas.
Yep.
He is saying here, tables, iterates, schedule stops, attribute value, and itinerary might have several schedule
Yeah.
stops, and each stop have dozens of attributes. Itineraries
Yep.
has tens of thousands of rows. Um, is a best practice a star schema a valid option here, or is it efficient to have a dim table for it itineraries with so many rows? Thanks, Maestro.
Um, Here's the thing. That's a very good question because it faces an important point, which is when you design a data model for analytics, what drives you is not which data you have, but which questions you have to answer. And if you say, oh, I don't have the questions yet, okay, but the model you create is a model to answer questions. It's not a model to represent the data that you already collected. The classic example is you have an OLTP system, right? A system that actually, an ERP or sales, or a system on the web to do direct sales to customers. And that the goal of the data, so usually these systems have a database, a relational database most of the times, and this database is designed to collect the data with the goal of making sure that the data is consistent and making sure that there is no data duplication, you don't lose information and so on. But most of the times, the consistency of the data is the more important thing, and also keep the data in a compact way, avoiding duplicating data and so on. So in a way, the database is designed to be uh, the first element responsible for keeping the data consistent along the food chain of the data consumption. Now, when we do data analytics, this responsibility is no longer in charge of the database. The moment we start creating a report, we do something in the middle. We transform data. We read data from a database. We read data from an Excel file. We read data from whatever. Now, this transformation moves the data from one model to another. Now, the destination model is not just, oh, we have to create a star schema. So we have to start from the data we have, and now we have to write a star schema. That's not the point. The point is, in our original system, we have, I don't know, 30 tables, completely fully normalized. So sometimes to navigate, to get the data for one customer, you have to navigate across 20 tables, just because you have to convert the zip code and the city name into the state, and then from there you get the country, then you get information about the demographic and so on. So it's a crazy navigation across multiple tables. But this makes possible that when you have to change an attribute for example, a city, the population of the city, you change that population in a single place, done. Now, when we do analytics, we don't have this problem, because at the end of the day, what happens is that there is a system that is responsible for moving this data into a different format that is optimized for the consumption. What is the maximum, the best way to optimize for consumption? Oh, I have to create a report that has 4 columns. So I have to create a table that has 4 columns. It's the best thing you can do. If you only have to do one report, you just want to create a single table with exactly the data that you have to put in the report. Now, because we want to do multiple reports, and maybe we want to enable people to navigate into the data with a system like Power BI, a pivot table, or other clients that exist in the world, it's better to create a structure in the model, in the relational database, that makes it easier to translate the desire of the report author into some query and into some data navigation. The goal is different. The goal is we have to understand what is the kind of navigation into the data that we want to use. And so we design the database according to this requirement. In a way, I would say I will start the designing of the database for the analytics, ignoring the data that I have. The first thing I do, I ask, okay, what do you want to do? What are the business entities you want to analyze? Which information you would like to analyze? And once I have my list, then I say, okay, let's see if we have this data, because maybe that we don't have enough data. This means that I could discover that there is data I have that I don't need. I'm missing some data that I need. For example, I need the population of the country, on the city and the states, because one important KPI they want to analyze require that information that I don't have. So I have to collect this information from somewhere. But the way I structure the data starts from this analysis, not from the data I have. So the point is, to answer the question, we have this structure, which is usually like a hierarchical list of information with many levels of details. And how we should we translate this into a star schema? Because this is complex. But the problem is, do you need this information? What is the analysis you want to do? Once you establish the analysis, we decide. Example, we have to analyze mainly the distance covered from point I to point B. And so this means that, so the goal is to analyze the trip. So the trip is your entity that you want to analyze, and what are the attributes of the trip that you need? Or each stop in the itinerary is important. Okay, so is the stop an event we can consider, or the list of the stops should be also aggregated into a higher level entity, which is the entire trip? And in that case, how many times I want to analyze one, I want to analyze the other, how many times I want to correlate the two? Should I, at that point, once you have these information, you say, okay, I need a single fact table, I need 2 fact tables, I need other dimensions. These fact tables should be correlated. And why do we use the star schema? The best practice, because it just works.
Right.
It's simple, it works, and it solves a number of issues. The last of the issues that it solves is the performance. The main issue that it solves is standardizing how to create a data model to do analytics. Okay, that is the more important thing. Everything else is, secondary. There are variations from the star schema. We have the snowflake schema. We have a few other things, but the differences are small. And sometimes there are some, something that is better from some tools. So, for example, in Power BI, we like the star schema more than the snowflake schema, but we enter into the technical details of the implementation. How we design the model for Power BI, for Tableau, for ClickView, for business objects is the same. To be honest, there are no differences in the initial analysis of the problem from my point of view.
And I think that's fantastic, Marco, because a lot of people come in asking that, like, hey, this doesn't fit, what I'm trying to do in this specific use case. Like, I don't have a good path to the star schema for that. But you're exactly right. Sometimes you vary, right? And that's when I think understanding best practices evolves to knowing when to break the rules and when to say, hey, you know what? For this use case, we're not going to follow that. The best practice actually isn't the common path, right? So, that's a beautiful question, and actually, potentially, I'm going to say a good transition over to a pre-submitted question that we have, and so we're going to go over. I'm going to read this out.
Yep.
This was submitted by Daniel Woods. He said he's working on creating a basket analysis on a star schema model. It's got a few billion records. It's highly optimized, so it's less than 3 gigs in size. But when he follows the basket analysis outlined on DAX patterns, both the regular and optimized patterns are very slow. What best practices or tips would you recommend for solving this challenge? Right.
So if you want to show my screen, so we are talking about this pattern, which is the basket analysis, which we publish on daxpatterns.com. So we have here a number of let's say examples of KPIs we can extract from a database that has a list of transactions, where imagine you have an order. In each order, you have several products. So we want to analyze the basket, so the products that are part of the same order. And there is a first implementation that, so basically this is what you get, right? So for example, how many orders both this category together with another category or with a specific product and so on. For example, from computer, Contoso optical mouse, which are the more common other products that are both together. And there are KPIs to the statistical KPIs like the confidence, the lift, that suggests you how strong is how strong the correlation is. Now, problem is that this calculation could be very expensive. So if I show you the data model, give me one sec. So the data model initially is this one. So you have the classic star schema, sales and product, and then you duplicate the product table to create this a model where you select 2 products or 2 categories. And once you have this information, you write some DAX code that does a lot of, let's say, temporary tables to compute these kind of sequences or these kind of combinations. So the pattern, of course, has a cost. So if you analyze the, I would say this is a good example. In order to see whether something is part of the same basket multiple times or not, we have to do this calculation. And this calculation has a very high cost that is this summarize. So this summarize basically is like a distinct count of how many unique orders have that intersection of products. And in order to do that, you have to get all the orders that have a product A, all the orders that have product B. It's expensive. Now, if you think about this problem, so one optimization is to try to, let's say, create a calculated table that already creates the number of orders and products that have a particular set of combinations. So this optimization that is explained in the article already improved the performance. I mean, it should improve the performance. I don't know exactly why who wrote the question said that the optimization pattern is slower. Actually, it is possible because of a way we implemented this to keep a certain degree of flexibility. But so if you think about the problem is the following. So imagine you have many products. The more products you have, the more combinations you might have in a single basket. A basket is like what you have in an order. Imagine you go to Walmart or any big supermarket, and you buy 1, 2, 10 products. Now, if you enter into a shop that has 100 products, the number of combinations you have is limited to the 100 products that you have. So it's a large number, but it's a finite number. When you have 100,000 products, it's the number of combination grows, but grows not in a linear way, in an exponential way, so that you have too many combinations. And because of that, it's hard to, usually we have to do some calculation at query time. Now, the principle that can simplify this, so the first evaluation you have to do is, forget we have a computer, forget we have something that is fast. Imagine you have to do this work manually. If you have to do, and imagine that the cost of lab, so imagine that, okay, two conditions that are impossible today. One, you have people that can work without a computer, impossible. Second, the cost of the labor is low, impossible too. But imagine that you live in this world where you don't have computers, but you have a cheap labor that can do the manual stuff. Even though you don't have to pay much and you have many people available, you will never have an infinite amount of people available, and you will always have to wait some time, because based on the number of people available, you have to wait that they complete the task. Now, what do you do at that point? You try to simplify the algorithm. For example, I have 100,000 products, but guess what? The analysis I want to do may be limited to the first 1,000. Well, we reduce the number of products to evaluate by 2 orders of magnitude, which means that we could start saying, okay, let's ignore 99% of the products. Good. Then once you do this reduction, maybe that the combination of products you might have in the same order are often the same. So if you can recognize a pattern in terms of a sequence of products that are together in different orders, you might simplify your, let's say, database, so that instead of watching each order one by one, maybe you say, wait a minute, when we store the order, when we archive the order, let's already mark if it corresponds to, I don't know, a common sequence that we usually see. And this is another thing that will save time when you want to do the report. We apply the same principle. So just because the computer is fast and is cheaper than human labor, it doesn't mean that it is a cost zero, and it doesn't mean that it is faster than the light. So we always have to try to simplify the algorithm to reduce the complexity if we go too high. So the idea is that if you really have now, I think that he said it's millions of rows, not billions, because with billions of rows, of course, it's a very complex problem. But the variable that is more important is how many products you have and how many combinations you can have in the order table.
So that was where that's kind of where I went. He said there was 18,000 potential products, or 1,800 potential products, which felt fairly low to me. But I'm wondering, as we look at these solutions and we think about that first question, is this potentially a different modeling that we should be looking at to solve this?
Well, so
right, if we're trying to like simplify our dependencies, right?
I understand. So it's we enter into, so conceptually, you want always to provide the 2 products and say, I want to see how many baskets have these 2 products together.
Right.
So the issue of this approach is that you want to know, so an easy way to solve the problem would be to duplicate the basket for all the possible combination of 2 products that you can have together, which is actually the example of this optimization. But the problem is that when you do that, and number of products is very high, you end up with another very large table. So the concept is that this should simplify and make it faster. But if you end up having a table that is bigger than the initial table because you don't have the same combination repeated multiple times, then it's an issue. So again, here's the statistic that is important. You have to understand something about the distribution and how you could figure out a way to organize the data so that even though you spend some time to prepare the data, you get a better performance later. Give an example. If the number, let's say that you have many products, but you want to consider only the top 4 or 5 products in an order, or a selection of a few products in an order. This limits the number of possible combinations you can have. And at that point, you could say, I have 1,000 different baskets, but in reality, there are, thousands of baskets that are just the same basket repeated multiple times. So different customers bought the same combination of things. Well, this is another element that could simplify. So instead of saying I have an order with a list of products, I have an order that matches one basket, and the basket should be unique but repeated in multiple orders. If I can achieve this kind of, let's say, optimization in a model, I reduce the number of, so I can get the which are the baskets that satisfy my conditions. So I translate my condition, product A, product B, into a list of potential baskets in a limited list of baskets that I want to consider. I reduce this to a smaller list that I apply as a filter to the table that already has one order, one basket. So instead of going at the level of the detail of the order, I stay at the order level. Usually you have like 1 order of magnitude of difference. Imagine you have the order and the list of the products in the order. If you have an average of 10 products per order, when you are able to analyze the order, not the products, you reduce from 1 order of magnitude the complexity of the problem. I know this could have a big cost in terms of data preparation, in terms of storage, that is possible. But if you want to keep the flexibility of having a very quick report, you have to prepare the data in a way that operation will be fast. But it really depends on the distribution of the data. I have seen several different approaches to this problem. But when the number of products grows, to hundreds of thousands, you have to find some smart solution. And as I said, usually the idea is that you locate the top products that you are interested to, and then you prepare the data for those products. That usually is a big advantage. If you cannot do that, you have to accept that every time you want to do this analysis, it is expensive. And maybe that at that point, instead of using Power BI, that necessarily has to use a technology that, let's say, repeat the same calculation at runtime every time, you prefer to create like a store procedure or a procedure in another language that generates a table that then you analyze. Classic report, like, just because we have Power BI doesn't mean that we have to use Power BI for everything. So it's possible that
right. Just use paginated reports, right, and hit it directly. And
why not?
I think that is a great response, and and piggybacks on the whole concept of like really understanding what these best practices are. All right, we've got a question from Andre. He's asking, do you think the Kimball methodologies are still up to date regarding data analysis modeling, or should we be changing that? Should we be pivoting from that best practice way?
This is a classic. So from which point of view? Because when I think to Kimball, I think to the way we analyze a problem. If you read Kimball that says, oh, we when we designed this in this relational database, we had this performance. Of course, that part is obsolete. But that part is maybe 5% of the book. It doesn't matter. So to me, the thing is, so in which part exactly Kimball is obsolete? Because I don't get it. Whenever I have seen a few articles or people saying that without providing substantial evidence about that. And by evidence, I mean, oh, Kimball wrote this many years ago, and now everything changed. I mean, guys, sorry, but the way we compute. So let's talk about something else. So, profit and loss statement of a company. We should change it, right? Because I mean, there's been so much time.
So old, yeah, right? Like,
So, there are details that we can discuss. So if you want to start a conversation about, I don't know, degenerate dimensions or junk dimensions, let's talk, right? Because why not? I mean, we can, but we are talking about a few details. And by the way, it's from my point of view, nothing really changed. But depending on the tool, there are a few details that can be tuned in a way or another. For example, from my point of view, the fact that we have to use the star schema in Power BI is a limitation we have because of Power BI. Because ideally, I would like to use a snowflake schema, not a star schema. There are many cases, especially in complex models, where a snowflake schema will work better. But because Power BI doesn't have a logical layer of the data presented to the user separate from the physical layer that describes how the table is stored, just to clarify my conversation. If I had the information of the customer in 3 different tables, I would like to have a view that shows in a single object, in a single container, the attributes of the customer, regardless of where these attributes are in the physical data model. Which means that if I have a snowflake schema, I should be able to represent the snowflake schema as a star schema or better. The dimension customer should be the dimension customer or better. The entity customer should be the entity customers regardless of the number of tables behind. That should be an implementation decision I should make. This is not possible for a design decision that Microsoft made many years ago, and now it's too late to change and too expensive, so they're not going to change it. You can write on ideas 20,000 votes. They will not change it. So it is what it is. So we can live with that because at the end of the day, it's always possible to translate your, let's say, snowflake schema into a star schema from the point of view of Power BI. But again, tell me one software that doesn't work well with the star schema.
So I think the articles I've seen to kind of actually defend this point to some point is when you look at like software like Databricks or these other MPP platforms, the joins are exorbitantly expensive and they don't perform very well. So having all the data in one long line and one huge table.
But I would argue that these tools are not tools that work with a semantic model.
I would agree completely with that. I just that was the argument that I think a lot of people put out.
It's not an argument because I mean what I mean is if I had to create an ERP, the star schema is not good. Of course, I'm the first one saying don't use the star schema for an ERP. No problem. So again, if you want to create an entire pipeline of transformations to create one report, fine. You can use many, many, many tools. But if the purpose of your, let's say, if you want to create a model, if you want to create a storage of data that can be easily used by users who don't have any technical expertise, the easier way to create an artifact or an application that navigates into the data without requiring to the user that consumes the data technical skills to navigate into the data, then you need something that we call a semantic model. And the best way to represent a semantic model so far from many years of research and tests and blah, 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 is the dimensional model. Now, you ask me, is the dimensional model the only way to create a data warehouse? No, of course, there are many others. But when it comes to the data mart, which is the way you present the data to the user, because there is a data warehouse, there is a data mart, so there are a number of layers that now nobody talk about. No, we use gold, silver, and what is
Bronze.
the other?
Bronze.
Bronze, which is fine. I mean, it's the same thing with another name.
Yeah.
Fine, no problems. I have seen also, but I mean, over the years, many name changed, but it's the same concept, right? So you
Yep.
have data that is not ready to be consumed, and then you have data that is ready to be consumed. And you might have data that is ready to be consumed without any particular navigation. So it's just a static report. I don't know if you heard, but you certainly heard about operational data store or something like that. And so the way, so if you show the tools that sometimes people use today, and you move this back in time, oh, this would be classified with just another name, which is not a data warehouse. But again, you don't have to create a data warehouse or a data mart just because someone told you it's a tool that you can use if it provides you an advantage. So if your problem is better solved by using tools like Databricks, fine. But it's a different, uh, let's say,
So
goal that
you're
you have.
saying one tool doesn't solve every need on the planet?
No,
Right. It depends, right? Oh, dang it.
no, the answer is no.
Yeah, yeah. Well, you're right. You're right. It is no. It doesn't depend. There's no one tool that solves every
Yeah.
need, right?
There is another thing that I like to say. A product will not pay your debt. When you, let's say, talking about best practice, because the topic is best practice. Let's say that you say, no, I don't need, so doing this is too expensive. Let's go straight this way and create the table this way. I don't care about the best practice because this works and works better for my, okay, good. Now, usually when you make this choice intentionally or unintentionally, because you didn't know that something would have had some consequence. Think about the bidirectional filters in a Power BI model. You could start something creating what we call a technical debt. Now we call technical debt because usually is related to the technology. And sometimes a company, so let's take a look at this from a 10,000 foot, so very high level. Imagine a company that does this systematically because they don't invest in training for the employees, they don't invest in whatever. They don't have time. They say, no, we have other priorities. So sometimes it makes sense. But this, so you accumulate data that you don't clean, you don't worry about that. It's like, oh, I get all this data, I move this data into, XML file. Then one day we said, no, XML, why XML? Let's do JSON. Okay, JSON file. And nobody worried about the data quality or other things. What they are doing, you are creating a technical debt. The day you want to analyze this data, guess what? This data is not good. Oh, maybe this data, there are duplicated rows here. And so this is the kind of technical debt that you move over time. And my point is that when there is a new product, many people think, oh, this product will solve my issues, my problems. But when the problem is a technical debt that you accumulated over time, the bad news is that the product you buy, so you spend something, but what you're spending is not going to cover the previous debt that you have. Unfortunately, usually it doesn't work this way. And so that's something that you have to, especially when we work in data, there is always a price to pay. You don't validate the data in a form. You're going to have people that will spend time in accounting, try to reconcile some duplicated customer. Then you have someone that will make a wrong decision when you count the number of unique customers that you have. Then you say, oh, but so now we have to use a MDM, master data management, to do that. Again, if you think rationally, so this is usually caused by an initial issue, an initial technical debt that you created. And what I always say is that it's when you have a loan and you don't pay the
That grows and it grows, right?
exactly. Yeah, that
Oh yeah.
you get the point. So that's the problem. So in data, this is very common, and of course, I'm
Well,
the
in
first
IT,
one.
it's very problem. It's very
Yeah.
common, and I think it goes to like why we're having this conversation. Why do we take on best practices? It's to avoid
Yeah.
technical debt, right? And to individuals that has problems, to organizations that has challenges. I think it. Yeah, that makes a ton of sense because it will bankrupt you no matter what when you unless you really know what you're doing, when to avoid that technical debt, or when the best practice is to not follow a class, a standard best practice. That does make good sense, and that's where the value is. So,
Yep.
all right, we have another question here that I kind of like. This is coming from oh Consonant. I don't think I got that right, but we tried. Um, is it best practice to have one fact table per process? He works in manufacturing. There's be hundreds of processes and hundreds of fact tables, or how do you like to
Mm.
differentiate, or how do you determine when to group things into a fact table versus breaking it out?
That's a good question. So
Good
clearly,
questions.
I hope that the audience will follow what I'm gonna say because it's very specific to the star schema and so on. So the question is a question about uh, imagine we have two extremes, and I try to simplify the question because probably not everyone is used to the problem of the process in an transformation processes in an industry. So to simplify the concept, let's say you have um, I mean, it's very, very high level, but let's say you have sales. So you imagine you have a system that, like in Contoso, we have sales that we produce on the website. So people connect to the website and order online. So if you think about this, we order online. We have a customer because you need to provide an address. You have to provide a name. You have to complete the payment. But we don't have a location of the sale. The location is the web. Okay, you could say this customer comes from there, but the web is is something that doesn't have a position. On the opposite side, you can sell the very same product in a brick and mortar store that has a physical store in a city, in a street, but we have no idea about who the customer is because if the customer enters the shop, pay cash, and go out, we don't know anything. So we don't know the name, we don't know anything. So if you think about the problem, it's the same fact from a certain point of view. It's we sold the product. However, the attributes we have about the transaction are different. In
Mm-hmm.
one case, we know the customer. In the other, we don't. In one case, we know the store. In the others, we don't. So one element could be the cardinalities of the dimensions, or better, the
The
details, the
grain.
dimensional
Yeah.
detail that you have, the grain. Yeah, correct. However, you could say, well, but I could say I don't know the customer or I don't know the store. That's an option. So you could merge them, right? So it's a decision you can make. It's not impossible, and you could have an additional dimension that tells you this was um, web sale or store sale. So just
Yep. A type dimension. Yeah.
the problem is that when this increases, so sometimes so it's easy to make the choice when you have only two fact tables. It's pretty much the same. Usually, we prefer to have two fact tables because, of course, with two fact tables, we have more freedom to add other dimensions, to add specific measure for a specific store. If we mix everything together, we have a lot of rows that makes sense only when you filter something, and that is usually bad. Having a fact table where there is some information that should be ignored when you are filtering something else, that's not a good idea. You want to have something that is simple. Best practice. Keep it simple. Keep it simple, always work. Now, the problem is that when you when you go in an industry where they have, we describe a few process, right? And a process could be the transformation of a material into something else. Imagine a company that produces cars, and like Tesla does now, they get the steel and they produce the car. That's the idea they want to achieve, the raw material input and final product output. But in the middle, there is everything. So
Mm-hmm.
what happens in the middle? So it's complex to understand. And again, it depends on the analysis you want to do. If your goal is to analyze the process as an abstract entity, I want to know how many processes I did and how many hours of human work I spent and how much raw material I spent in the processes. A single fact table is good, because at the end of the day, you are not interested in the specific attributes of the different stages of the production.
Right.
At the same time, if you want to include all these attributes and you want to create a single table, it becomes impossible to analyze, because you have like thousands of columns and only 2 or 3% are relevant for a specific row. So you don't want to do this. So what is the right balance? Again, what should drive you is the kind of analysis you want to do. I will not say that there is a perfect model that works every time. It depends. Again, if I want to analyze the process from the point of view of the process, I do one choice. If I want to analyze a specific process because it has attributes that are important for my analytics, I do something else. And if you think about imagine for a moment how you will design the report to navigate into your data. That's the best way to start. Okay, imagine that someone will do exactly what you want. What do you want in your dashboard? What do you want in the filters? What do you want? If you realize that when you have thousands and thousands of attributes, you don't want to see all of them. And so probably you start saying, okay, wait a minute. I want a high-level dashboard this way. Then I want another one for this area. Well, I don't care about those ones because nobody cares about that. And this is how we start. So at that point, we create one or more models, because it is not mandatory to create a single model. You could create 2 or 3 models. We call them data marts. So usually the classic book says you have one data warehouse and many data marts, and the data mart is department specific. I would say analytics specific. So for a specific analysis, you do one data mart, one model in Power BI. The notion of data mart is a single semantic model in Power BI.
Sure.
But you have the data flow, right?
Yeah.
What is the purpose of the data flow? To create the same content in different semantic models. So it's like we have a shared dimension, but when you have the same dimension used in different models, in different data marts, you have the same dimension produced from the original entity in the data warehouse. And this is something similar with different names, but the principle is similar, very similar.
I think that's absolutely fantastic, and I also think that this leads well into our next question when it comes to like, we were just talking about best practices, or how do we manage our fact tables, but how are we going to improve upon the work we do? And so what's the next big thing you see coming out in the Power BI space that helps enable best practices? I'm going to tack that on to Matthias' question. That helps enable best practices for people in the space.
I don't have an answer.
Oh.
From my point of view, I didn't see any announcement that is important on this side. I mean, yes, of course, we have a number of technologies that will help us to, let's say, do quicker and do faster what we do today.
Mm-hmm.
But I didn't see any announcement of something that we can validate. And I explain why I'm saying this, to be a game changer. Let me explain. It's clear that my reference is toward Copilot and AI. I'm a user of this system, so I know I reasonably know what I'm talking about. And my experience so far is that these are tools that empower people who know the matter.
Mm-hmm.
They are not tools that enable people to do something they cannot do alone.
Mm.
That's the situation today. It could change. I'm not saying never say never. So in 5 years we could see a different picture. But the evolution of Copilot, for example, Copilot for Visual Studio and something like that, it's not a game changer. For my, I mean, I'm too conservative, but it's I didn't see any evidence. The hype we have now is about the idea that we think that we will be able to do something. Okay, nice. But what is an actual proof that this works? Because the test I did so far with the technologies available is it's not better than what we have without. And again, I don't want to mention DAX in this case because I could be biased. Let's talk about SQL.
Sure.
As of today, generating SQL from a prompt doesn't work in production. You can see some of them, I know. There are demos that work, I know. But please read the paper. It's boring. They are long. They are boring. Read the paper and check the cost, the human cost that is required to enable a model to generate the SQL code. It doesn't worth the effort. It's actually, if I remember, the one that I have seen in a white paper. The last one was 2-3 months ago. It's like 10 times the cost, between 10 and 100 times the cost for producing a semantic model with Power BI for SQL, right? So
well, that sure is like a deal breaker then, right? Like,
I mean, the problem is that okay, so this specific white paper, this specific paper was describing an idea they had. It was, okay, if we train enough models with real databases, then a new database will be solved automatically by the generative AI. But they found two problems. One is that the training the training required a lot of human work to explain to the AI what the model was doing. Because imagine you have a set of tables, you don't even have the formula. Think about this. You don't have the formula. So you just have numbers in columns and names, and based on that, something should generate the SQL code. And actually, at the end, they obtain something that works. But here we enter the second problem. The database that they were able to use were public databases, like, students and grades and professors, something like that. And they write, it is written in the paper. I mean, I can provide you the link. They wrote, we don't have access to company databases. Of course, I mean, so I think, let me think. Most of the bigger companies in the world use SAP.
mm-hmm.
Then there are other ERP. And SAP has field names that are in like 8 characters, letters that could have
With
different
German abbreviations.
Yes, they are German abbreviations, so they are in a different language. And wait a minute, because I don't know, but in different customization, the same field could have been used for completely different purposes. So I say, okay, let's say that, but even though you train on an SAP, they didn't do that because they trained on like 30 tables and SAP has like hundreds.
Right.
So I say we are very far because the problem is who is going to provide the information about explaining what is in each field? Because I don't know. I mean, if someone explain me how this will work, because the best that the AI can do as of today is to establish correlation between information that it had. But when there is something new, it's hard to relate if there is no correlation with anything.
Sure.
And again, so because if you think for a moment, I would not start from the relational database. I would start from another point of view. For example, if you have SAP, you have HANA, which is a system like, a semantic model. I would start from there. But again, so if the semantic model is something that is, a higher level. SQL to navigate a semantic model. I mean, it's not impossible. I understand that, but it becomes complex. DBT is trying to do something like that, but the kind of expressivity they have is very limited. There is a reason why in many years we have seen just 3 languages for querying a semantic model, which are MDX, which is used by multiple industries, also from SAP. We have seen Click, we have seen DAX, and probably there is something else. But all these languages have in common that they don't they are not SQL, because in SQL you have the problem that the relationship is not part of the language, and so and that is the additional problem in SQL is that when you change something, you have to completely rearrange the shape of the query. So the best solution that many people found is that, okay, we create another way to describe the model so that the SQL code will be generated automatically, which works. But the problem is that how do you generate the formula? Because the formula has to be injected into different kind of joins and different kind of correlated subqueries that could change the shape. And so it's hard to understand how to combine the language so that it will continue to work. It's just a question of how do you solve practical problems. I'm not talking about I'm not biased. I love SQL. I mean, but there is a reason why people spend so many years creating other languages. And I didn't see a good explanation, theoretical explanation that says, we can do that because I didn't see that. So how can I believe that this will work? I don't see any evidence. Again, I don't see any evidence, but we have evidence that MDX works. Let's forget DAX, okay? Let's forget it. MDX works. It has its own defects, but it works. And it worked for many, many years. Are we able to create the same thing in SQL? As far as I know, no. There is a reason why business objects stopped it and went to MDX with SAP. I'm not talking Microsoft intentionally, because otherwise Microsoft made this choice. No. Let's look. So
a question. I didn't know that SAP uses MDX for HANA.
Yeah.
Oh.
You can. I mean, you can connect the pivot table in Excel, and Excel generates MDX. So yeah, why not?
I just didn't know that that's the protocol or the tech that they were using.
If you look, I hope I'm not saying a stupid thing, but
to the
I'm sure, because I have seen SAP HANA. If you search on the documentation, you have maybe it's a subset of it. So then we enter into the story, which part of MDX is supported, and maybe it's not the same, blah blah blah. But the basic thing is that you create a pivot table in Excel and you navigate straight to SAP HANA with the driver, all the DB for rollup, and it just works. So.
All right then. I mean, that is fantastic. And I now we have a whole bunch of more questions here, and I'm terribly sorry. We have already exceeded our time with you, Marco, and so we're exceedingly grateful for that. Before we sign off and log off, I know you have a number of new products that you've recently released. Could we? What's that?
No, it's not that are my products. I contribute to this product, because otherwise it seems that I work as yes, I work a lot, but not enough to realize everything you see now. So if you want to show the last one is the PBI Explorer. which is a tool that actually has a minimum involvement from my side, beside the fact that I'm part of the same company, Tabora Tools, that produces this tool. This is a free tool. Also, Matthias Tierbach working on this tool, but also other people in the team. And it's a tool that can compare two versions of the report that can be viewed as a hierarchical structure. So the elements, the visual, the pages, the bookmarks that you have in a report can be navigated like they are, a hierarchical structure. And that is an initial version. Of course, there will be something more in the future. The other one is a DAX optimizer, which is a service to optimize DAX that basically works starting from the statistical information you can extract with the VPAX file, the Vertipack analyzer that is embedded in many products like DAX Studio, Tabulator, Bravo, and probably many others. And you basically get this file that doesn't have any data, and DAX Optimizer finds suggestions to improve the performance of the measure that you have. The statistical information about the distribution of the data in columns and tables is important to establish the priority. So you might have 1,000 suggestions for your model, but the first ones are more relevant for the performance of the entire model. So it's not an optimization of a specific report, it's an optimization of the entire model. In our experience, it's a static analysis. It's not based on the consumption on the query that you run.
Sure.
But in our analysis, in our test, usually when you have a slow report, the slow measure are also, very high in the suggestions, in the ranking for the suggestions provided. So usually it works also for optimizing a specific report. But the idea is that you should be proactive. So you should optimize before the user says this report is slow. So that's the goal, to avoid that you deploy something that is slow.
Well, that is just fantastic, and so please do check that out. I know it's a paid service, but I didn't think the price point was aggressive on it, especially for what it can do.
It's as you can imagine, the problem of the pricing of this tool is that basically you could use it only once.
Right.
If you have it, you don't have, you could just use it once and that's it. So yes, we have subscription because the idea is that if you have a team and you want to, let's say, continue to apply to review what you do during the development, so that the number of fixes that you have to do should be limited, then there are subscriptions. But otherwise, you can just buy the single analysis, and it costs a fraction of any consultant that you might have. So the way to see the pricing is that you have to let's say you have to pay years of investments here, because that's I'm scared to say, but the initial idea of this product is 2014, so before Power BI.
Wow.
So
well,
yeah.
but you are spot on, right? Like if you hire a consultant to come in and go through and do all the evaluations, it's horribly expensive, and that's why I'm saying it's a great value for anyone to come in and take a look at that. So
that's it. It certainly cannot solve all the problems. I want to be very, very honest, but it usually helps you a lot. And of course, it's a version 1. We are still in preview, so there is a wait list now, but we should very, very soon reach the public. So we will remove the wait list. We will increase the documentation. We also fixed a number of things, but we will not go, let's say, GA, because we still have a couple of features we want to implement, especially for enterprise features. And so maybe in a few months, it will be also generally available. So when it is in beta, it's also, there is a discount, because during the beta we know that there is something to fix, and of course,
a little bug here. We work at Power BI. We're familiar with public preview stuff, so that's
I know.
Well, Marco, thank you so much for taking your time to stay up. What is it, midnight where you're at, or what time?
No. It's 8:10 p.m.
Oh, okay. All right. So that's
No,
not terrible. Well, thank you
no,
for
no, no. It's fine. It's fine.
for joining us. Thank you all for connecting and being so lively in the chat. This has been fabulous. Next week we're gonna keep this up and going. We've got in a park. He's gonna be coming. He's gonna be talking generative AI and Power BI. So let's see if Marco can be swayed through this
Yep.
presentation to that. So thank you guys all so much, and we will see you later. All right. Peace.
Thank you very much. Bye.
Bye-bye.
Bye bye.
Baker Tilly Digital combines strategic industry insight and advanced technical expertise to uncover and solve your digital transformation challenges. If you're interested in learning more, check out our website at bakertilly.com/digital.